Project Pluto. In the late 1950s, as the Cold War escalated and nuclear arsenals grew, the United States launched one of the most ambitious and terrifying weapons programs ever conceived. It was called Project Pluto, a plan to build a nuclear-powered cruise missile that could stay airborne for weeks at a time, travel at supersonic speeds, and carry multiple nuclear warheads directly into Soviet territory. Unlike conventional missiles, which had limited range and predictable flight paths, Pluto was designed to fly indefinitely, weaving across continents, avoiding detection, and delivering devastation on a scale never seen before. At the heart of the project was the supersonic low-altitude missile. Its engine was a nuclear-powered ramjet, a reactor that would heat incoming air to generate thrust. Once launched, Pluto would skim just above the ground at over 3 times the speed of sound, hugging the terrain to evade radar. The shockwaves from its passage alone could shatter windows and rupture eardrums, but the missile's true horror lay in its combination of endurance and payload. Even more disturbing was the fact that the nuclear engine would spew unfiltered radiation as it flew, leaving a trail of radioactive contamination across whatever countries it passed over, whether enemy or not. The project advanced further than most people realize. In the early 1960s, scientists successfully built and tested prototype nuclear ramjets at the Nevada test site, proving the concept was technically possible. But Pluto was a weapon too dangerous to deploy. The missile could not be safely tested in flight, as it would spread lethal radiation over American soil, and its uncontrollable flight path raised questions about whether it might spiral out of control and devastate allies or even the United States itself. By the mid-1960s, with the rise of intercontinental ballistic missiles offering faster and cleaner delivery of nuclear weapons, Project Pluto was deemed unnecessary and too hazardous to continue. It was officially canceled in 1964, leaving behind blueprints, prototypes, and the chilling memory of a weapon that could have turned the atmosphere itself into a battlefield. The Soviet Ekranoplan. This Caspian Sea Monster was the largest aircraft in the world when it first appeared in 1966, a prototype ground-effect vehicle nearly 100 meters long and weighing more than 500 tons, designed by the Soviet Union to fly a few meters above the water while traveling at speeds of more than 500 kilometers per hour. Known in Russian as an Ekranoplan, it exploited the aerodynamic principle of ground effect, where a cushion of high-pressure air formed beneath the wings during low-altitude flight, allowing a machine of extraordinary size to skim across the surface with efficiency and speed that ships could not match and conventional aircraft could not sustain with such heavy payloads. The vehicle was constructed in secrecy and moved to the Caspian Sea for testing, where American reconnaissance satellites first detected its enormous shape. It was powered by 8 jet engines mounted at the front of its fuselage. It demonstrated an ability to carry troops, armored vehicles, or heavy missiles across vast distances at speeds faster than any naval vessel while remaining below the detection range of most radar systems. Soviet military planners imagined fleets of Ekranoplans operating in the Black Sea and the Pacific, able to strike carrier groups or deliver nuclear weapons directly to coastal targets. And in theory, the combination of speed, payload, and low observability made it a formidable new tool of Cold War strategy. In reality, the machine was extraordinarily difficult to operate, as flying just meters above the waves at such velocity left no room for error, and after years of trials, the Caspian Sea Monster crashed in 1980 and sank, ending the life of the prototype. A successor, the Lune-class Ekranoplan, was completed in the 1980s and armed with 6 supersonic anti-ship missiles, but like its predecessor, it never advanced beyond experimental service. By the time the Soviet Union collapsed, the Ekranoplan program was already regarded as too costly, too impractical, and too vulnerable compared to submarines and long-range bombers, and it faded quietly into history. Project Horizon. In 1959, at the height of Cold War rivalry, the United States Army proposed one of the most ambitious and extraordinary projects in military history. Known as Project Horizon, it envisioned the construction of a permanent American base on the surface of the moon. The plan was drawn up as a strategic installation designed to extend American power beyond the Earth itself. The base would be built into the lunar surface, using underground chambers to shield its inhabitants from radiation and meteor strikes, and it would be capable of housing dozens of soldiers and scientists who would live and work in a self-sustaining environment supplied by nuclear power and regular shipments from Earth. Military planners believed that control of the moon would mean control of the future battlefield. From such an outpost, the United States could monitor satellites, conduct surveillance directly over Soviet territory, and even position nuclear weapons in silos carved into the lunar rock, ready to be launched at a moment's notice. Beyond its military utility, the project was also a political weapon. The presence of American soldiers on the moon would serve as undeniable proof of U.S. technological superiority, a display of dominance that would resonate across the world and discourage Soviet ambitions in space. The scale of the project was staggering, requiring hundreds of Saturn-class rockets to deliver construction materials, machinery, supplies, and personnel to the lunar surface. The cost was estimated in the tens of billions of dollars, a figure that strained credibility even by the standards of the arms race, and the risks were beyond calculation. Yet, within the documents prepared by Army engineers, the timelines were laid out with confidence, projecting that a fully operational lunar base could be completed by 1966. Ultimately, Project Horizon never moved beyond the proposal stage. Responsibility for the American space program shifted to National Aeronautics and Space Administration, which pursued the Apollo program and prioritized reaching the moon with short-duration missions rather than establishing a permanent colony. Project Iceworm. In the early 1960s, the United States launched Project Iceworm, and its objective was the construction of a vast underground network of tunnels carved into the ice sheet of Greenland, where hundreds of nuclear missiles could be hidden, maintained, and moved from site to site. By dispersing launchers across thousands of kilometers of shifting ice, the United States hoped to create a system that could not be located or destroyed in a first strike, ensuring the ability to retaliate at any moment. The public cover for the operation was Camp Century, a supposed Arctic research station established under the supervision of the Army Corps of Engineers. Officially, it was presented as a demonstration of how human beings could live and work in extreme polar conditions, powered by a small portable nuclear reactor. In reality, the camp was only the first step in a far larger plan to build a hidden missile complex beneath the surface of Greenland. Prefabricated tunnels were laid out under the snow. Laboratories and living quarters were installed, and surveys were made to determine whether the massive ice sheet could support long-term military infrastructure. The answer came quickly and decisively. The Greenland ice cap was not a stable foundation, but a shifting, flowing glacier, and the tunnels that had been so carefully constructed began to warp and collapse under the slow but relentless movement of the ice. The dream of an underground missile city disintegrated in less than a decade. By the mid-1960s, the project was abandoned, and Camp Century itself was closed, leaving behind contaminated waste and radioactive material entombed in the ice, where it remains today. Project Iceworm remained classified for decades, its existence hidden even from the government of Denmark, which formally controlled Greenland and had never been informed of the true purpose of the camp. Duga Radar. In the 1970s, deep inside the forests of Ukraine, the Soviet Union constructed one of the most powerful and mysterious radar systems ever built. Known as Duga, it was part of the Soviet Early Warning Network, designed to detect American intercontinental ballistic missiles as soon as they were launched. The installation stretched for hundreds of meters, a colossal wall of steel antennas rising above the trees, its scale so vast that it could be seen from space. The system began broadcasting in 1976, transmitting signals at shortwave frequencies that echoed across the globe. To radio operators, the sound was a constant, repetitive tapping that interrupted broadcasts, communications, and even civilian electronics. The noise was so distinctive that it quickly earned a nickname, the Russian woodpecker. From Europe to North America, anyone with a shortwave set could hear it, and its unexplained presence became a subject of fascination and anxiety. Western intelligence agencies soon traced the signal to its source near Chernobyl, but for years they could not confirm its exact purpose. Conspiracy theories flourished. Some believed the transmissions were a form of mind control, designed to influence populations through subliminal frequencies. Others suggested it was a weather modification system or a secret weapon to disrupt communications worldwide. The truth was less exotic, but no less significant. Duga was an over-the-horizon radar, bouncing signals off the ionosphere to track potential U.S. missile launches thousands of kilometers away, giving the Soviet leadership precious minutes to respond. The system was plagued by technical problems. Its massive power demands strained the grid, its accuracy was inconsistent, and its interference with civilian broadcasting drew constant complaints. Still, it remained operational throughout the late 1970s and into the 1980s, a symbol of the Soviet determination to guard against nuclear surprise. After the Chernobyl disaster in 1986, which contaminated the surrounding region, the Duga facility was abandoned. Operation Ivy. In November 1952, on the remote Inuiatak Atoll in the Pacific, the United States carried out a test that marked the beginning of the thermonuclear age. Codenamed Mike, it was the first detonation of a true hydrogen bomb, a device that used nuclear fusion rather than fission alone, unlocking the same force that powers the stars. The project formed part of Operation Ivy, an effort to prove that fusion weapons could be built and deployed, and it represented a decisive leap in destructive power at the height of Cold War rivalry. The Mike device was unlike any weapon ever seen before. Weighing more than 80 tons and housed inside a building rather than an aircraft or missile, it was never meant for practical use, but as a demonstration of principle. When it was triggered on November 1st, 1952, the result was staggering. The fireball grew to nearly 5 kilometers across in seconds. The mushroom cloud rose more than 30 kilometers into the sky, and the blast yield was calculated at 10.4 megatons, over 700 times the force of the bomb dropped on Hiroshima. The island of Alujalab, where the device had been installed, ceased to exist. In its place was a crater more than a mile wide and 50 meters deep, instantly filled by the waters of the Pacific. The explosion vaporized everything in its path, and the shockwave shattered instruments and structures far from ground zero. The United States had proven that fusion bombs could work, and that the scale of destruction available to humanity had now expanded to a level previously confined to science fiction. Thank you so much for watching this video, and if you learned something, make sure to leave a like. Subscribe if you would like to see similar videos. Thank you again, and goodbye.